Hi dear friends, today we try to understand the concept of Lvdt. It is a motion sensor wherein we would like to measure the displacement of an object. Actually Lvdt stands for linear variable differential transducer. It is a type of transducer which converts a displacement into an electrical signal. Okay, it works on the principle of inductance. Okay, the mutual induction concept is used to convert a displacement into an electrical signal. Okay, in this video we will cover the concept like construction of Lvdt, working principle of Lvdt, applications of Lvdt, and also the advantages of Lvdt. Coming to the concept of Lvdt, so how does it exactly appears, looks like? So it's like a rod structure as shown in the bottom. Okay, and herein actually the complete structure, like what exactly the different electrical components are present, so everything is enclosed within the rod. Okay, so you can observe that there is a cross-sectional diagram, means after on taking a cross-section of this rods, so you can see this cross-sectional diagram. So wherein just a second, wherein you will have one primary winding, two secondary windings, and there is a ferrite core which is movable. Okay, usually in this diagram it is moving horizontally, and the horizontal displacement it is shown like this. Okay, so what is the construction details you will be understanding. It has a one primary winding, two secondary windings, and one movable iron core or a ferrite core, and in the bottom you will be having equivalent diagram for the same Lvdt cross-sectional area. So here you can observe there are two secondary windings, like secondary winding A, secondary winding B, and one primary winding, and between them there is a ferrite core. So the object which you would like to measure the moment of the object, so that is connected here. So there is an arm between the core and the object. That arm is used to connect or used to transform the object moment into a core moment. Okay, so now we will try to understand how exactly we can write in the examination. So you can draw this cross-sectional diagram. Okay, there is one primary winding, two secondary winding, core, and core is connected with a arm toward and the displacement of the object is fed to core. Okay, so you can observe here there is a primary winding electrical equivalent model and two secondary windings electrical equivalent model. It's a kind concern that you supposed to make one distinction between the connection between two secondary windings. So you can observe here, so first secondary winding is taken in a reverse way and secondary winding will be connected, and the output of the first secondary winding is E0 of 1 and the output of the second secondary winding is E0 of 2, and the difference between E0 of 1 and E0 of 2 is given by E0 is equal to E0 of 1 minus E0 of 2. Why the difference is coming? Because this output is going here and then it is fed back to here. So that's what E0 1, this voltage minus this voltage is my total voltage. So this is the electrical equivalent concept of this Lvdt. Now we would like to move on to the working how exactly core movement is working in this setup. Okay, so what exactly for core is used for? Can anyone those who knows? So here it is very simple. The core is used as a coupling element between primary and secondary. Okay, whenever the core is exactly at the center, so you see here the signal is coming throughout the primary winding, but only the secondary winding. See, this core is allowing some part of the primary winding to be coupled with secondary winding, and it will give you a mutual induction at the secondary winding. So here also the some part of the primary is coming to secondary winding, and there is a mutual induction is happening, means this voltage is available, this voltage is also available, and you will take a difference between these two voltage as a final output voltage. So this is a case where the how the core is working whenever it is at the center. If the core is moved towards the top side, then what happens? Even though there is a mutual flux available here downside of the primary winding, so it will not be connected to secondary winding because there is a no core present between them. So that's what there is no coupling is happening. Okay, coupling means like mutual induction is happening. So here the core is acting like a media or a mediator between the primary and secondary windings for the coupling to happen or a mutual induction to happen. So that's what the core is acting. Core is acting like a coupling element between primary and secondary winding for the mutual induction to happen. Fine. So now we will try to understand how exactly the LVDT works. Okay. Actually, what is our actual target? Our actual target is to identify the displacement caused at the object, right? So object is connected to core. So that's what I would like to divide the operation or the principle of working of LVDT into three major parts. What are those? You know, it's very simple. Whenever core is moving along a horizontal axis, it can take a three positions. Okay, one is core is exactly somewhere towards left side. Okay, another point is whenever the core is exactly at the center, and the third part is whenever core is towards the right hand side. So you're supposed to explain or you're supposed to understand this LVDT concept on considering three core positions. Okay, on considering three core positions, you can easily explain the working principle of LVDT. So first position, we will consider the first position like core is towards the left. What exactly happens? Okay, so I feel like I need some pointers to be used. Just a second. Okay, fine. So I'm using one pen. See here, whenever the core is here, okay, then there is a chances of mutual induction to happen between this primary and this secondary. Okay, so I am taking two lines to show the mutual induction is happening between primary and secondary. Okay, now you can observe. Do you feel like any mutual induction is happening between this secondary core and secondary core and primary? No, because there is no core is present between them. Okay, actually we have seen in the previous slide, like core is acting like a coupling element between primary and secondary. So the core is here, so it is allowing the mutual induction to happen here. Okay, so now at the secondary there is no core, right? So that there is no mutual induction from primary to secondary. So that's what E naught of 2 is your 0. Why? Because there is no mutual induction is happening. When you come to here, there is a mutual induction is happening, as of which some positive voltage you will get at E naught of 1. So that's what is the total output voltage? Total output voltage is equal to E naught 1 minus E naught 2, and E naught 1 is positive value. Okay, E naught 2 is 0. So that's what the overall total E naught value is my positive value. You can observe here. Okay, and this is shown in this characteristics diagram. Okay, like it will be like this, you can observe. Okay, after this the curve is non-linear. Okay, don't worry about it because we are interested in the part of linear characteristics of the LVDT. So that's what up to here we are in interest. Okay, so that is what how exactly LVDT works for the left hand side core availability. Okay, now you may ask, like, sir, why we have taken all these points? See, actually the core, I have taken only one position of core in the left hand side. This core is not taking a single position, right? It is taking a movement here. So it is taking movement because of object is moving. So that's what you may get a different values of output voltages, and all those different values of output voltages I have plotted in a as a line. Okay, this non-linear characteristics I am not interested in, so that's what I am leaving it out. Okay, fine. So this is how exactly LVDT works whenever the core is exactly at the left hand side or moving in the left hand side. Fine. So now I'll move on to the next part of the working of LVDT. In the next part, what I will be taking, whenever core is exactly at the center, what exactly happens? See, you can observe here, core is exactly at the center. Okay, so what exactly happens? Some amount of mutual induction can happen here, right? And equal amount of mutual induction can happen here. Okay, isn't it? Equal amount of mutual induction can even happen here. So that's what E naught of 1 and E naught of 2 both will be of same amplitude. Fine. So that's what, if I take a subtraction of these two, E naught is equal to the E naught 1 minus E naught 2, then what exactly you will get? You will get a 0 value. Okay. And in the characteristic you can observe, at whenever my displacement is 0, I am getting a 0 value. So what is this axis? This is a core position axis. And what about this axis? This is my output voltage. Okay, so you can observe that this output voltage is equal to 0 because my E naught 1 and E naught 2 both are 0. Okay, both are same, and if I take a subtraction of them, it will become 0. Okay, shall we move? Okay, in the third part of same LVDT explanation, or a third working principle of this LVDT, third part or a third core position, if I take, then it will be at the right hand side. You can observe, if my core position is at the right hand side, okay, what exactly happens? So yes, what exactly happening? Yes, in the third place, third core position, mutual induction is happening to the secondary winding. Okay, mutual induction is happening to the secondary winding, and it is giving you your output voltage E naught of 2 as a some value, right? It is giving some output voltage E naught 2 as a value and E naught 1 as a 0, isn't it? Is it clear, everyone? So fine, I feel like I can take once again this pen and I have to explain it. Just a second for a while. Okay, just fine. Okay, fine, just a second, sorry. See, in the secondary winding 2 you will get some output voltage. Okay, so and the secondary winding 1 you will not get any output voltage. Okay, so if I take a subtraction of these two, so you will have here, this subtraction will lead to 0 output voltage because first secondary winding will give you 0 voltage and secondary winding will give you some positive voltage, but the difference of these two if I take, then it will become negative value. But you can observe my plot is of magnitude, okay, or modulus. So that's what my output voltage, even though it's supposed to go in the negative direction, but because of modulus, so I'll be taking only in a positive direction. So this is what exactly the linear part of my right hand position of the LVDT core I am taking. And you can observe that these are the nonlinear characteristics which we are not interested in. Okay, so that's what where exactly my LVDT characteristics lies. Okay, where exactly my LVDT characteristics lies? It lies between this. Okay, so you can understand. Okay, now there will be one question in our mind, like why do we say a linear variable differential transducer? It's very simple. Like my output characteristics is linear, right? My output characteristics is looking like linear, and my output is a variable value. It's not a fixed constant, right? And even my output is a difference between E naught 1 minus E naught 2, right? So that's what linear variable differential transducer it can be said. Okay, now we will move on to the concept of what are all the different applications associated with LVDT. So you can observe here displacement. I already stated LVDT is used to measure the displacement. Okay, and also the deflections of beams, strings, and certain sorts of rings, right? You may observe in many activities rings, strings are also used. So if we would like to measure the example like gymnastic and all, if we would like to measure the displacement of strings and rings also, we will use the LVDT. And next one is like pressure, right? To measure the pressure, force, and also to measure the weight. Okay, one of the best example they have shown it here, so you can observe. So here there is a pressure is applied. Okay, just a second. You can observe here. Here the pressure is applied, right? Pressure is applied like this. Okay, it can be felt by this Borden tube. Okay, and the amount of displacement whatever it is happening that can be carried by a cord or the arm. Okay, it is connected to a core through pulley. Okay, so when when the pressure is applied, then this core will move. Okay, normally this core movement is vertical right now because it is connected in such a way that it has to move in a vertical position, right? So this is my source from where I am applying my electric signal. See, Lvdt is called as a passive transducer because it requires certain external power supply. Keep that in mind. And it is also a analog transducer because my output is coming in the form of analog. You see there is a needle. Okay, so that's what. So next, based on this movement, based on the pressure, this core is moving, and based on this movement, the mutual induction can happen here or can happen here, and accordingly I'll be getting a different output voltage here. Okay, so this is what how exactly a Lvdt can be used to measure the displacement. Fine, clear? Okay, next part I'll be going for the advantages of Lvdt. Okay, so you can observe. So it is used to see for a small change in the applied displacement, there will be a large change in the output voltage. So this is one of the very good advantage we can have, and its cost is less because one type of transformer is required, nothing else, because mutual induction is a concept of principle of operation, and it can be used. It can be very useful in case of different environment, like it may be like rainy or any season, any environment it can be used. So that what is the reason? Because it's a very solid and robust component, as you have seen in the construction. How does it looks like? It looks like a rod, and it is covered with metallic structures and all. So that's what you can use anywhere in any environment. Okay, and it also tolerates or withstands an external additional displacement. If it is applied, then also it can withstand without any damage. Okay, no permanent damage can happen because like every structure is very strong and built in a tube, right? Fine. So if the desired range goes out, then also it can work properly because the core moment is there, nothing no any hardware wear and tear is happening. So that's what it can withstand if any undesired range of displacements are applied to a Lvdt. Okay, so this is what exactly Lvdt is, what does it stands for, it is what for it is used, and what is its constructional detail, what are the working principle, and also what are all the applications, and what are the different advantages compared to other motion sensors. Fine, dear student, I feel like today you understood the concept of Lvdt. We will come with next other concepts of motion sensor and other different sensors. Thank you for your patient listening. We will wind the session today. Thank you.